वेरी गुड मॉर्निंग स्टूडेंट। आज की क्लास में हम लोग डिस्कशन करेंगे प्रिपरेशन ऑफ हेलोअल्केन। प्रीवियस क्लास में हम लोगों ने हेलोअल्केन को क्लासिफाई किया था डिफरेंट कैटेगरीज में, और आज हेलोअल्केन को हम लोग प्रिपेयर करेंगे बाय यूजिंग डिफरेंट मेथड्स। सबसे पहले देखते हैं व्हाट आर द मेथड्स आर अवेलेबल by which haloalkanes are prepared. The first one is from alkene, second one from halogen acid, third one from alcohol, fourth by halogen exchange reaction, and fifth by side chain reaction. तो सबसे पहले हम लोग यहाँ पर एल्कीन से प्रिपेयर करते हैं। एल्कीन तो अगर हम हेलोजन के साथ रिएक्शन करा दें X2 मीन्स हम कुछ भी दे सकते हैं, क्लोरीन दे सकते हैं, ब्रोमीन दे सकते हैं, आयोडीन दे सकते हैं, फ्लोरीन दे नहीं सकते, इसका रिएक्टिविटी बहुत ज़्यादा है। और यहाँ पर रिएक्शन को करने के लिए मीडियम का रिक्वायरमेंट होता है, तो सॉल्वेंट नॉर्मली कार्बन टेट्राक्लोराइड यूज होता है। और यहाँ पर प्रोडक्ट हमें मिलेगा डाइहेलोअल्केन। वेरी इंपॉर्टेंट मेथड by which we can prepare haloalkane. एल्कीन को हम यहाँ पर इस तरीके से ले सकते हैं। जनरल फॉर्म में एल्कीन को हमने ले लिया और X2 के जगह में हमने Br2 या एक्वस ब्रोमीन, और यहाँ जो सॉल्वेंट है कार्बन टेट्राक्लोराइड CCl4। अब हमें क्या करना पड़ेगा कि यहाँ कार्बन कार्बन जो डबल बॉन्ड है उसमें एक बॉन्ड है सिग्मा, एक है पाई। फर्स्ट बॉन्ड इज सिग्मा and the another bond is pi, and हम लोग सभी को जानते हैं pi bond is weaker as compared to that of sigma bond। तो इसमें बॉन्ड का क्लीवेज होगा, कौन सा बॉन्ड का क्लीवेज होगा? pi bond, एंड कार्बन कार्बन के बीच में डबल बॉन्ड जो है वो कन्वर्ट हो जाएगा सिंगल बॉन्ड में। अब यहाँ पर कार्बन अपना वैलेंसी लॉस कर रहा है, टेट्रावैलेंट हो रहा है, यहाँ पर कार्बन ट्राइवैलेंट हो रहा है। तो जहां पर कार्बन कार्बन में सिंगल बॉन्ड है वहां प्रत्येक कार्बन के साथ ब्रोमीन को अटैच कर देना है। तो यहाँ पर ये डाइहेलोअल्केन तो बन गया, साथ ही साथ यहाँ पर दो कंसेक्यूटिव कार्बन पर हैलोजन लगा हुआ है, तो देयरफॉर इट इज 1,2 dihalide, and it is important to note that 1,2-dihalide is also known as vicinal dihalide। अब मान लेते हैं यहाँ पर हाइड्रोजन को डाल दिया, और हाइड्रोजन को डालने के बाद हमारा प्रोडक्ट में भी क्या आएगा? हाइड्रोजन सिंपली ऐड हो जाएगा। तो ये जो है जैसा एल्कीन हम लेंगे, जैसे यहाँ पर कार्बन कार्बन डबल बॉन्ड के साथ लेफ्ट और राइट में दो हाइड्रोजन अगर हम डाल रहे हैं तो इथीन बन रहा है। तो यहाँ पर ये क्या बन जाएगा? 1,2-डाइब्रोमो इथेन। IPC नेम इसका लिख सकते हैं 1,2-डाइब्रोमो इथेन। अब इसका मैकेनिज्म सेगमेंट में अगर हम बात करें तो यहाँ पर ये मैग्नाइज्ड होगा साइक्लिक हेलोनियम आयन से। साइक्लिक हेलोनियम आयन इसमें बनेगा जो रोल प्ले करेगा रिएक्शन इंटरमीडिएट का। जिसके बारे में हम लोग क्लास 11 में ऑलरेडी पढ़ चुके हैं एल्कीन चैप्टर में, इसलिए यहाँ पर इसको फिर से अभी डिस्कशन नहीं करेंगे। यहाँ हमारा फोकस क्या है कि एल्कीन से हेलो अल्केन को कैसे हम लोग जनरेट करते हैं। इसके बाद हम लोग यहाँ पर एक और मेथड है जिसमें एल्कीन का यूज होता है टू प्रिपेयर हेलो अल्केन। तो ये मेथड हम यहाँ पर इसका जनरल फॉर्म लिख रहे हैं, एल्कीन प्लस HX, HX यानी हेलोजन एसिड। और इसमें ध्यान रहे हमने यहाँ पर दो पार्ट में इसको करने का कोशिश किया है कि एल्कीन प्लस HX। एल्कीन सिमेट्रिकल भी हो सकता है, अनसिमेट्रिकल भी हो सकता है। नाउ देयर इज अ क्वेश्चन अराइज, व्हाट इज द मीनिंग ऑफ सिमेट्रिकल एल्कीन and unsymmetrical alkene? Now see this example of ethene. Both double bonded carbon atom consist of equal number of hydrogen. So such type of alkene are considered as symmetrical alkene, and if the number of hydrogens will be different, then such type of alkene will consider as unsymmetrical alkene. Suppose if I write CH3. Now the number of hydrogen atom both sides of the double bonded carbon atom become unequal. So this is unsymmetrical alkene. So it depends upon the number of hydrogen atom attached to the double bonded carbon atom. In case of equal number of hydrogen, it will consider as symmetrical, and in case of unequal number of hydrogen, it is considered as unsymmetrical. So alkene may be symmetrical or unsymmetrical, and HX stands for halogen acid, and H acquire positive charge and X acquire negative charge. So the halogen acid is also example of unsymmetrical reagent. So when both alkene and halogen acid interact in the same condition, both have the same condition, unsymmetrical, in that condition Markovnikov addition takes place. And what is Markovnikov addition? The Markovnikov addition suggests that in case of reaction of unsymmetrical alkene with unsymmetrical reagent, the positive part of the reagent is added to that side of the double bond carbon which consists maximum number of hydrogen atom, and the negative part is added to that side of the double bonded carbon which consists of minimum number of hydrogen atom. So if Markovnikov addition takes place, then positive and negative part, these are the part of the reagent. Positive part attach that side where maximum number of hydrogen, and negative part is attached to that side of the double bonded carbon where the number of hydrogen atoms are minimum. So whenever Markovnikov addition takes place, the haloalkane may be 1 degree, 2 degree or 3 degree. It completely depends upon the nature of the alkene. But same reaction if takes place with HBr. HBr is also a part of halogen acid, and reaction is take place in presence of peroxide. Then reverse of Markovnikov addition take place. Positive part attached to that side of the double bond carbon which consists minimum number of hydrogen atom, and the negative part attached to that side of the double bond carbon which consists of maximum number of hydrogen atoms. And whenever alkene reacts with HBr in presence of peroxide, as we have stated right now, that reverse of Marconi's addition take place, and this effect is known as Carboxyl effect. So, reverse of Marconi's addition, or rather you can say anti-Marconi's addition or peroxide effect. Generally, it results the formation of 1 degree haloalkane, or you can say that lower degree of haloalkane can be prepared by this method. Now, I will try to solve both of these methods with the particular example so that it will be easier for all of you to understand. And there is a short notes type question comes in the examination, that is write notes on Marconikov's and anti-Marconikov's addition. So first of all, I will show the example of Marconikov's addition, which is causing the formation of haloalkane, and then we show the example of anti-Marconikov's addition. So see this, CH3, Ca, double bond CH2. Here you can see the double bonded carbon atom consists unequal number of hydrogen atom. So it is an example of unsymmetrical alkene. This is propene, and it reacts with HCl. It is also an example of unsymmetrical reagent. Now, if both are unsymmetrical as I have stated, Marconikov's addition will take place. The positive part is attached to that side of the double bond carbon, which consists of maximum number of hydrogen atom. So H will add it to this side, right hand side of the double bonded carbon atom, and Cl attached to the left hand side of the double bonded carbon atom. Now let us see what product we have generated. We have generated halogen is attached with the CH, so it is 2 degree haloalkane. First of all, we'll write this. It is 2 degree haloalkane, or rather we can say that 2-chloropropane according to its IPC name, and its common name is bit more important as compared to that of IPC name. It is known as Isopropyl Chloride. It is Isopropyl Chloride. Wherever there are 3 carbon atoms and the branching or any particular functional group attached to the 2 degree carbon atom, see this carbon atom is 2 degree because the number of adjacent carbon with respect to this are 2. So therefore it is considered as 2 degree carbon atom. So what I have stated, that whenever a functional group attached to the 2 degree carbon atom and the number of carbon atom in the parent chain are 3, then we can use iso, and 3 carbon alcohol is pro-ine, and for chlorine it is chloride. Now there is most important part of this particular reaction. Here you can see that both reactant and reagent completely added to each other, and after the reaction it forms saturated product. There is no double bond. So it is an example of addition reaction. The above example is an example of addition reaction, and addition reaction is taking place by the three different reactive species, which may be electrophile, nucleophile, or free radical. So in this case, the addition reaction is taking place by the help of electrophile. So it is known as electrophilic addition reaction. It is known as electrophilic addition reaction. In class 11, you have go through this particular reaction with its mechanism. So I am not getting mechanism of this reaction in this particular segment. So it is an example of addition reaction, or rather electrophilic addition reaction, and what product we are getting? We are getting HaloAlkane. So Marconi's addition is useful to prepare higher degree of HaloAlkane from alkene. And now there is another example, CH3, CH, double bond CH2, and it reacts with HBr. In presence of peroxide, whenever you will observe that reaction taking place in the presence of peroxide, and the reactant and reagents are alkene and halogen acid, it will result the haloalkane of lower degree. And reverse of Marconi's addition, most of the time we used to write like this, anti-Marconi's addition, and it is just reverse CH3, CH2, CH2, Br. This will be much more simplified, will be like this. This is the part where the minimum number of hydrogen atom, and this is the part where the maximum number of hydrogen atom. So what peroxide effect indicates? That positive part of the reagent attached to that double bond carbon, which consists of minimum number of hydrogen atom, and the negative part is attached to that side of the double bond carbon, which consists of maximum number of hydrogen atom. So this is known as peroxide effect, and this reaction is only shown by HBr. HCl and HI do not perform this particular reaction, and why it's not formed you can solve from your past. And this is the 1 degree HaloAlkane, and its name can be written as N-propyl, because there is a straight chain, so you can write N-propyl, and for Br it is bromine, and we are generating 1 degree HaloAlkane. If you want to observe the mechanism of above reaction, the reaction which I have discussed right now, you can watch my previous lecture by using my YouTube channel. So here I am not going to explain this, and this is also an example of addition reaction, because both reactant and reagents are simply added together. So it is an example of addition reaction. And what type of addition reaction? This type of addition reaction is taking place by the help of free radical. And who are responsible to generate the free radical? The peroxide is responsible for the generation of free radical. So it is an example of free radical addition reaction. And any reaction which may be addition or substitution, if taking place by the help of free radical, then there will be three different stages. So step 1, chain initiation, step 2, chain propagation, and step 3, chain termination. So the first part of the question we have already completed, how haloalkane generate from alkene, and second method we have also discussed from halogen acid. And reactivity order of halogen acid is, I have already mentioned few minutes back. Reactivity order is HI greater than HBr greater than HCl greater than HF. HI is most reactive because its bond strength is very minimum, and that's why it took part in the chemical reaction very readily as compared to that of any other halogen acid. So up to this, very clear. From alkene we have prepared, from halogen acids we have prepared. Now the very important method for the preparation of haloalkane by using alcohol. So let's see what are the different types of reaction includes in this category. Here, to minimize the time, I am going to use some general forms so that by using those general forms you can write the reaction. This is the general form of alcohol, ROH. An alcohol may be of 1 degree, 2 degree, 3 degree, that is another thing. The first method, if alcohol is treated with phosphorus pentahalide, and what is that? PX5, it forms RX plus HX plus PuX3. And depending upon the nature of alcohol, haloalkane may be 1 degree, 2 degree or 3 degree. If the reaction is carried out by using phosphorus trihalide, again haloalkane generated and byproduct will be H3PO3 orthophosphorus acid. If the reaction is carried out by using thionyl chloride, SOCl2, again RX plus SO2 plus HCl, in place of X we can write chlorine, and the last one HX, RX plus water. So in the given examples, you can see that the OH group of alcohol is simply replaced by halogen atom. So it is an example. These type of reactions are the examples of substitution reaction. Substitution reaction, and if the given alcohol is of 1 degree, the product, that is haloalkane, also will be of 1 degree, and so on 2 and 3 degree. So by putting the value of R, by choosing the R, and R represent the alkyl group which may be simple or branch, doesn't matter. You can choose any type of R, and if such type of reagents are used then what we have to do, we have to simply replace the hydroxyl group by the halo group. And there is another very important reaction in this category, ROH treated with HCl and anhydrous zinc chloride. This mixture is known as Lucas reagent. Result the formation of RCl plus water. And this reaction very effectively used to distinguish between 1, 2 and 3 degree alcohol. You will ask me how? The answer is very simple. That 3 degree alcohol undergoes the reaction very rapidly. So on 2 degree and 1 degree alcohol is very least reactive. And by the reactivity we can understand that what type of alcohols are given or given. Now you will ask me that how the reactivity of alcohols are different. To understand this particular concept, you have to understand the mechanism of bond cleavage in alcohol. There are 3 different types of bond cleavage occurs in alcohol, and which are oxygen hydrogen bond, carbon oxygen bond, and there are some reactions of alcohol are also observed in which both carbon oxygen and oxygen hydrogen bond taking part in bond cleavage. And in the given reaction, simply carbon oxygen bond, R means carbon, alkyl group means carbon, carbon oxygen bond undergoes cleavage, and as the bond cleavage takes place, reaction intermediate will be formed. And as we know very clearly that high degree reaction intermediate is highly stable, and for that reason 3 degree alcohol after the bond cleavage form 3 degree carbocation, and 3 degree carbocation is highly stable, so 3 degree alcohol has greater tendency to show this reaction, and therefore the reactivity of alcohol 3 degree greater than 2 degree and so on 1 degree, and last there is no degree. So I hope that up to this particular point we have already clarified each and every single topic in elaborate form. Now there are 2 more methods are still remain. 4th one is by halogen exchange reaction. So see how this reaction takes place to perform the formation of haloalkane by halogen exchange reaction. The first reaction in this category is Finkelstein reaction. Finkelstein reaction. And what is the rule of Finkelstein reaction? The rule of Finkelstein reaction is to prepare iodoalkane RX plus NaI or I plus NaX, Ri plus NaX Rx stands for alkyl halide, and the X may be chlorine or bromine but not iodine. So this method is used to prepare iodoalkane. This method is used to prepare iodoalkane, and it is known as Finkelstein reaction. And it is important to note that this reaction taking place by applying heat. Now again there is a question that why we are using the heat sign, because a minimum amount of energy is needed to break this carbon halogen bond. And all of us know that carbon halogen bond is highly polar. So it has the maximum bond strength, and to break the bond a certain amount of energy is needed, and that's why we are putting the sign of heat, or we have to apply a certain amount of energy. So this is halogen exchange reaction. There is an exchange of halogen. If we write an example, CH3Br plus NaI, we are getting CH3I plus NaBr, that is methyl iodide. Very simple reaction. These are, most of the time you will find in your examination papers, there will be fill in the blanks type question, and to solve those questions you have to have good concept. Now after Finkelstein reaction, there is another reaction that is also a part of halogen exchange method, and this reaction is known as Schwarz reaction. You should remember that Schwarz reaction is used to prepare the fluoroalkane. Since the reactivity of fluorine is very high, there is no direct method is available by which we can prepare fluoroalkane. So Rx plus AgF, the product is Rx plus AgX. So it is an example of halogen exchange reaction, and the X never be fluorine. X may be chlorine or bromine in case of haloalkane that we are choosing. So this example is indicate that again the halogen exchange is taking place. This halogen is exchanged or replaced by fluorine. So it is an example of halogen exchange reaction, and when it takes place, when haloalkane interacts with heavy metal chloride, if we used SbF5 antimony pentafluoride, again the result will be same. Byproduct may be different. So these are the methods which are involving to prepare HaloAlkane. And the last but not least, Hunsdiecker reaction. Hunsdiecker reaction. What is Hunsdiecker reaction? This reaction is used to prepare bromoalkane, and for that we have to take silver salt of carboxylic acid interacts with Br2. Silver salt of carboxylic acid interacts with Br2 and CCl4 is the solvent, and refluxing we are getting the product RBr plus CO2 plus 2Ag, simply AgBr, not 2, simply AgBr. So above reaction is used to prepare bromoalkane. And what is the specialty of this reaction? This reaction involves the decarboxylation. Removal of carbon dioxide is taking place, and by decarboxylation reaction it forms HaloAlkane. So it is very important. Silver salt of carboxylic acid, silver salt of carboxylic acid. So you can put any type of alkyl group to get your result. Now this reaction in terms of mechanism is also very important, and you have never gone through the mechanism of this reaction. So we'll try to solve the above reaction by giving its mechanism. So watch carefully so that you can understand the mechanism of this reaction. At first, write silver salt of carboxylate or silver salt of carboxylic acid in the given form, and it interacts with the bromine, and it interacts with the bromine like this, and it will result Br partial negative, partial positive. So it will give the formation of AgBr. This is the first step. Silver salt of carboxylic acid interacts with bromine molecule, and it results the formation of AgBr as a byproduct. And now choose this one. Here we are generating free radical. This free radical is known as carboxylate free radical. Carboxylate free radical. And again choose this carboxylate free radical like this. So we are getting alkyl free radical with the formation of CO2, and finally alkyl free radical interacts with bromine. It results the formation of RBr. That is the main product that we are trying to find out. So it is the mechanism of Hunts-Dicker reaction, and it is also proceed through the help of free radical. So we have completed the four very important methods to prepare haloalkane. First by using from alkene, second by using halogen acid, third by using alcohol, and fourth one is by halogen exchange reaction. Only one method is still remaining that we'll discuss in our next class. Till then, goodbye and note it down all this thing.